But yeah, welcome to week 3. Today we're going to be using what we built off, or we're going to be building off of what we learned from last week. So we're going to be using some constraints and stuff like that. But now it's going to start to play kind of like a background role. So I'm going to assume that you know how to use them, and then we're going to just use them when we need them, when implementing these um, new topics. We're also going to be going into assemblies, which is pretty interesting because that's kind of nice when you want to have more than one part together. Hello. Okay. So your next assignment is to basically recreate the engineering fountain. So what we're gonna do, similar to like the gear assignment that we did, is we're gonna copy different bodies. Last time we copied like profiles and sketches, but you can also do that with bodies, which is pretty useful. And then with this assignment, you're also going to learn how to use a canvas, which can be pretty nice if you're using something to reference something else. So let's boot up Fusion. Probably should have done that earlier. But you'll see in under resources, we have this nice starry photo of the engineering fountain. Usually when you use reference photos, you typically want to use something that is like a very like flat face, so you're not like taking like an isometric view of something, because we're going to be tracing it and you don't want to like trace something at an angle, if that makes sense. So keep in mind that if you ever use canvases, you might want to take like, if you're taking a photo of something, make sure it's like head on. And then sometimes you can use like a penny or like a ruler or something next to it to reference the geometry if it has to be dimensionally accurate. But for today, we're not really messing with dimensions, we're just messing with the canvas. So if you want, you can download this photo and then we're going to be using it for the assignment today. Okay, cool. So when we're in our environment and we want to insert a canvas, there's this big insert button with a photo next to it, and that basically tells you what it's going to do, right? You can see from this preview, they have like this drawing of a car, and then they use it as a canvas to actually design the 3D model. So we're going to use that to make the engineering fountain today. So I'm going to click this. I'm going to upload it from my computer, so find it wherever it is. And then it'll ask you to select a plane, right? You have to put it on a plane. I'm just going to choose like this right plane here. And then you'll see, if I zoom in, we have this engineering fountain. Over here on the right, you can see a bunch of things that you can change. Again, this is like totally up to you depending on your circumstance. Right here is like the opacity, so it's like how see-through you want it. You can always change this later, but you know, you can make it more or less. I'm just gonna leave it at 50 for now. You can have it like move to a certain position if you want that to be, or you can scale it. For me, I'm just gonna leave everything at default, but you can kind of see how you can use these parameters to, you know, scale and make your canvas the right size. So I'm just going to press OK. We have this nice canvas of the engineering fountain, and then we're just going to start making it. So like in most circumstances, we're going to create a sketch. We're going to choose the same plane that this fountain is made on, and then we're going to start drawing it. Now, if you didn't know, I believe the curve on the engineering fountain is modeled after the e to the x function. So fun fact for you. But that also means that you can't really use a circle when recreating this. So we're going to use something that we used last week. We're going to use the fit point spline. But first, I'm just going to start by creating the other lines over here. So this doesn't have to be very precise because we're just making a model or like a replica. I don't expect it to be perfect, but just like generally just trace the outline of the engineering fountain. So I'm going to be making some lines here. So, oops. So I have those lines. I'm going to make these perpendicular. So you can see I'm using constraints. These should be perpendicular. This one should be vertical. Okay, cool. So now these guys are like partially contained. I'm going to kind of pull them so they generally fit. And then I'm just going to add some dimensions here to fully constrain them. So I'm just leaving them here. These are like kind of weird arbitrary numbers just because I'm tracing. But I'm just doing this to fully constrain it. This is kind of like a good scenario where you could use the fix tool, but I'm just going to leave these dimensions here just in case I wanted to like scale this later. But yeah, now that I have like this L shape, I'm going to create a fixed point spline. Can't talk. But basically how it works is you just start specifying points that you want to be on the spline, and then it'll create like a really smooth curve between those lines. So technically speaking, the more points you have, the more accurate your curve is going to be. But also, if you have like a billion points, it's going to be super annoying to change later. So in my case, I'm just going to be doing like a couple points, and it should give me like a general idea of what this shape is. So again, the fixed point spline, you might want to zoom in because sometimes Fusion will kind of like snap to like nice numbers on the grid. So if you zoom in closer, you might be able to get a more accurate spline. So I'm making this curve here, and then once I finish, I click on, I ended it at this line, or that point. There's this little checkbox or check mark here, and if I click on it, it'll finish the spline. So I click on it, the spline is created, and now I'm happy. You can move points on the spline, so here I'm going to move this to the corner here. Maybe move this to the corner as well. And then you can also see when you click on the spline, there are these green lines that you can push and pull. You can use that to manipulate the spline as well. I mean, right now it looks pretty good, but like you can see if you wanted to change it for some reason, you can see how manipulating this could change the geometry of your spline. After that, I'm going to create two vertical lines right here. Again, I'm going to be using some more constraints. So I'm going to make these perpendicular. Sometimes it'll make them automatically, so you'll see it's already been applied, which is what I like. And then I'm just going to trim away the excess. So I'm going to trim this away. I'm going to trim that away. The sketch isn't fully defined, but you get the idea. Constraining splines can be kind of annoying, so I'm just not going to do that right now. But yeah, if you want to check to see like your sketch and like hide the canvas, you can go up to this canvas folder on the top left corner. There's this eyeball here. If you click on it, it'll disappear, and you can see the profile we've created. Again, if we can confirm that these two are nice and closed bodies because they're highlighted blue. So that's what we want. Again, this isn't fully constrained because of the spline, and I didn't specify these things, but it's okay for this scenario. Does everything make sense so far? Okay. What do people need help on? Feel free to shout at me. You guys are good? Oh, I just so if I'm gonna show the canvas again. But I made sure like 2 points on the spline were kind of at the edge of the two like concrete blocks of the engineering fountain, and then I drew 2 vertical lines going from those points to the bottom line we created earlier. And then I used the trim tool to trim away those 2 spaces in between. Raise your hand if you're not caught up yet. It's okay if you're not. Okay. Okay, is everyone good? I'm gonna continue. Okay, cool. All right, so now that we have our sketch, we're gonna extrude it, and then I'm gonna extrude it the wrong way first, just so you guys can kind of see the difference, and then I'm gonna go back and fix it later. So I'm gonna hide the canvas for now because we finished the sketch. I'm gonna extrude this, so I'm gonna select these two closed shapes, specify a distance, maybe, yeah. So I just extruded it like normal, so I extruded it to one side, but you're gonna see why that can potentially be an issue later. So now that we have one of the sides of the engineering fountain, we're gonna copy it. So just like we copied the gear teeth, we're gonna copy these bodies. So if you go under create, pattern, and then circular pattern, we're gonna copy these around in a circle. So I'm gonna select the bodies, so these two, which highlight in blue, and then the axis of rotation, I'm gonna choose this green line here, which is the center, and then I'm gonna specify the quantity at 4. So you'll see that the engineering fountain doesn't look like it should, and that's because of the way we extruded it, right? So we extruded it to one side, and you're revolving it around the origin, or the which axis? The y-axis. So because you're revolving something that's extruding and like protruding out from the y-axis, it'll revolve and it'll look kind of strange, right? This is not really what we're after, but there's a really easy way to fix that. So again, it's really nice that we can go back and change things. So down here in the timeline, I'm going to find the extrusion. I'm going to edit this extrusion, and then I'm going to change it from one side to symmetric. So that basically will mean that instead of extruding it from the profile plane in one direction, it'll extrude it evenly in both directions. So when I do that, I have to half my distance, because it goes, in this case, 2 in both directions, but I want the total width for me to be 2. Your number might be different. So I'm going to change this to 1, and you can see how it's the same shape and like it's extruded the same amount as last time, but this blue is where we made our sketch, and you can see how there's a little bit of extrusion on both sides. So that's what we want, and if I press OK, you can see how it's all centered correctly. In this case, my extrusion's a little bit large, so I'm going to make it smaller. Yeah. So if I make it smaller, it should look good. Okay. Is anyone confused on this with the symmetric extrusion? So if I want to change the extrusion, I can find it in the timeline down here. I right click it and I edit the feature, and then in the direction I changed it to symmetric. All right. Does this make sense? Yeah. All right. Okay, so now that we have the general shape, I'm gonna add a little bit of detail to the engineering fountain. So you can see in like the photo, there's like the little cutout with a little ridge in it. I want to add that detail for this assignment. So I'm gonna do that. Of course, there's many ways you could go about doing this. So now that we've created it, you could technically create like a sketch and an extrude and like extrude them all like piece by piece, but that's like really inefficient, right? We'd like to do it in like one fell swoop, if that makes sense, right? So what I'm gonna do is I'm gonna push the timeline back to before I made the circular pattern. I'm gonna modify the extrusions, and then when I put the circular pattern back, it should do it for all of them, right? Again, there's multiple ways of doing that, but I'm going to do it this way. So you can see this bar on the engineering fountain. I'm going to slide it back, and it's going to reduce it back to 1 set of extrusions. And then I'm going to edit this, and then when I push it forward, those changes should go to all of them. Again, if you're like CADing and you had the foresight to add the detail before, it's basically the same thing. But you can always, or this is just showing that you can go back and do things out of order if there's ever something that you want to add or change. So again, I slid this little bar back and I hid the patterned extrusions, and now I'm gonna create some more features. So I'm gonna create a sketch here. I'm gonna do it on this face. And then I'm gonna show my canvas again, and then I'm gonna start tracing. Another thing that's pretty useful is called like projecting, and that's basically taking a line or a feature that's on another sketch or extrusion and bringing it into the sketch that you're currently making. So in this case, like I kind of want to use like this horizontal line and this vertical line to create this detailed section. So I'm going to copy those into my sketch. So I'm going to press P. This project option will show up, and then I'm going to start clicking the lines I want. In my case, let's just say I want these. Oh, not that. I want these lines. And then I'm going to press OK. To make things easier to see, I'm just going to hide the bodies for a second. And you can see these purple lines are lines that were already created. So the nice thing about using projected lines is that if the base extrusion or sketch changes, these projected lines change with it. So if you're creating features that are dependent on other features, using these projected lines are really useful for, when one thing changes, it'll snowball and change other things with it. I just pressed P. P is the shortcut.
Just select the geometry and then press P.
Yeah. So yeah, I have these. I'm going to show the canvas, and then I'm going to start drawing in this detail. Again, like it doesn't have to be like super accurate to this engineering fountain. We're just kind of getting a general idea of what this looks like. Okay, cool. Now, if I hide the canvas, you can see that these spots are, these spots are highlighted blue now. So that means that they're closed bodies and we can like manipulate them, in this case, with an extrusion. So we like that. I know that was a bit fast, so is anyone confused about this? So to create the projection, you press P. Sorry. So are you in a sketch right now? Okay, so you first want to be in a sketch that is on uh so in this case, I'm making a sketch on this face because we're going to be cutting into this face. And then inside that sketch, I'm going to press P. I'm going to select these lines. I already did it, so I'm not going to do it again. But you can click on these lines, and then you press OK to project them. What's up? Okay. Is the body like? Are you showing the body right now? Like the body has to be visible. So if you look at the timeline down here, I made the sketch after I made this extrusion. Uh, the sketch is on top of the extrusion, and like you can hide the body, but I want it to be visible to select the line. So I'm just gonna do it again. So again, I'm making a sketch on this plane or on this face. So you see these bodies here. I'm gonna press P to open the project, and then if I go to the lines, they kind of like get bolded in black. So I'm gonna click all of these lines, and then I'm gonna press OK. And then when I do that, okay, it's getting mad at me because I think it's like trying to select the sketch. Is it saying that it's not visible for you? Because I may have already, it may be trying to select the invisible sketch. At least for me. I think the other thing you can do is just select the faces. Oh my goodness. Okay, yeah. So you can also just like project the whole thing by clicking on the faces. Yeah, I mean, I I can I guess you can. I'm sure if you okay. Is anyone confused with the projection still? Raise your hand if you are. Okay. Are you in a sketch already? Okay. Did you press P to open up this menu? Okay. The easiest way to do it instead of selecting lines is you can also just select the whole face and it'll project the whole face for you. Um, so it should highlight blue whenever you click on a face. It doesn't? Okay. Let's take a look. Okay. Do you still need help with the projections? All right. Okay, so at this point, I'm going to assume that you have this sketch here. And then what we're going to do is we're going to extrude it. So I'm going to select these two, and then instead of going out like this, I'm going to go in, so it's cutting it out. In this case, I'm going to do like 0.1. and then that's nice. Okay, so you can see that this side is detailed, but this side isn't. So there's a number of ways you can go about doing this. I think like I've showed you how you can mirror stuff. So instead of doing like a symmetric extrusion, you could do a one side extrusion and then you can mirror it after you've done all this. Um, in this case, I'm just going to do it another way just so you can see that there's multiple ways of doing things. So, okay, I'll actually just do it both ways. So before, um, it was like a one-sided extrusion and it made this detail. You can mirror it. So create mirror, and then you can mirror it on this plane, and then it'll copy the features with it. So that's one way. The other way, if we did it symmetrically like before, we can actually use the same sketch to extrude it again, but in a different spot. So again, I'm just showing you that there's more than one way of doing this. This way may seem more complicated, but depending on what you're modeling, it might be the way you want to do it. So over here, I'm going to extrude it again. I'm going to show the original sketch. I'm going to select these two. And then, oh, it's lagging a bit. So instead of extruding it from where I drew the sketch, I can extrude it from an object, which will allow me to select faces and planes. So I can select this side, and I believe it was 0.1, and then I can do the operation with the cut feature, and I get the same result, right? So again, there's no wrong or right way of doing things. Sometimes it's just a matter of personal preference or kind of depending on what you're going after. Like, let's say one side was supposed to be extruded more than the other side, then that's when this might be useful. Also, if you like make a mistake on where you sketched it, because some people, instead of sketching on the outer edge of this plane or of this face, they sketch it on the plane that goes through the center of it. That is also, this is a useful way of moving where you're starting to cut, if that makes sense. Because some people make the sketch in the middle, but if you change where the extrusion starts, then you can basically make it as if you made that sketch there, if that makes sense. That wording wasn't amazing. What's up? Oh, okay, you got it. So at the end of the day, we have this one full profile of the engineering fountain, and if we did it right, we should be able to just slide the timeline forward, and it will copy all the features to the other ones, like that. Does that make sense? So the last thing to do on this assignment is just creating a nice base for it. So I'm just going to do that real quick. I'm going to draw 2 circles. I'm just not going to bother dimensioning them for time's sake. And then I'm just going to extrude it real quick. Sometimes you'll have to select a face because in this case I selected this face as part of the sketch or as the plane that I'm making the sketch on. So sometimes you'll need to include that in your extrusion to extrude everything. Specify a distance, and then you're done. Yeah, that's this assignment. Again, I tried to show you like multiple ways of doing it just so you know that it's possible. But feel free to do whichever way makes you most comfortable. Because yeah, it's just one more sketch. I did 2 circles, so if you look at it, there's this blank circle in the middle. I just didn't select that when I went to extrude it, but other than that, it's just 2 circles. Yeah, I think it's in the slides. There's like a photo. But yeah, that's this assignment. Is anyone confused on this? We're starting to run short on time, so I might have to go a little bit faster for the yeah. Yeah. So all right.
If anybody has doubts on these, message me or meet me after class. I'll clear those doubts later on because we're running out of time.
Yeah.
Also for the joints thing as well, I'll be here after class for like 10-15 minutes. If you have doubts, you can ask me then. Otherwise, you can just message me on Discord and I'll hop on a call with you. I'm pretty quick to reply, and the call usually does not take more than 5 minutes.
Yeah.
So doubt clearing can be done here.
Okay. Yeah. So I'm gonna try to quickly go over joints. This can be a little bit annoying and confusing at times, so don't worry if you don't get it right away. You just have to be very careful on which edges you're selecting. All right. So for this assignment, your goal is to recreate this Lego car. So in the Discord, there's this zip file with all the models already. So if you want to download that, make sure you download it and then extract the zip file, because if you don't extract it, then you can't access all the data. I've already done that, so I've uploaded it here into my kind of workspace. To do that, you just press upload. You select files. You find all the files. You can highlight them like that, and then just press open. It'll ask you, or it'll help you confirm that you have all the parts that you want, and then you just press upload, and then it will be saved in your Fusion drive over here. I've already done that, so I'm not going to do it again. You can see I already have a small assembly, but I'll redo it. Also, if you ever want to organize something, there's this folder button here, so you can see how I made a folder with all the Lego car stuff just because there's a bunch of files and it helps me stay organized. But anyways, let's create an assembly. So basically what an assembly is it's taking multiple parts that either you or someone else has already designed, and mashing it into one big file. So it allows you to create and like build the parts before you make it in real life. So it's really nice, just to make sure that everything lines up correctly before you try to make something. And it's kind of cool to see your finished product in CAD before you make it. But anyways, you first have to start by saving a document. So I made a new design here. I'm going to save it. I'm just going to name it 2 because I already have one. So over here you can see I have this saved file, and with that I can start inserting parts into the design. So I like to keep this data panel open whenever I'm inserting parts. It's kind of cool because you can sometimes get a preview of them. So in my case, I like to start out with the biggest part, or like the part that I'm going to consider my base, right? So if we look at the Lego car, it's kind of hard to see, but we have this long 2x6 plate that extends the whole side of the car. And I'm going to use that as like the foundation for my assembly. So I'm going to find it, which is the 2x6 plate here, and then I can just drag it in. It'll take a second to load sometimes, but then it'll render it. Over here you can see that I can move it wherever I want, but for the first part I just like to put it or leave it where Fusion recommends, because it just kind of puts it near the origin. If it comes in sideways, here, I'll do it again. If it comes in sideways, you can see you can manipulate it in like kind of forward, backwards, up and down, but you can also rotate it like this. But yeah. So I would say the first thing that you should do after inserting like your foundation piece is grounding it. So grounding basically means that you're fixing it in place and not allowing it to move. So just kind of like how the origin is the only defined point in space, grounding your first part will make sure that every other part will kind of assemble itself in relation to your base part. So over here, I'm going to right click the part, and then I'm going to ground it. And over here you can see it's been grounded with the pin in the timeline. But now that we have one part, we can start adding more. So I'm going to start by adding this buggy wheel, or like the wheel and axle assembly. And you can see like sometimes it kind of phases into the part that you already have in there. What I like to do is I like to put it generally in the right area that I want it to be, but not perfectly in that area. And that will allow me to kind of visually tell if that part is actually assembled and like constrained. So for me, like it's going to be about here once I finish it, but I'm going to move it a little bit farther away just so I can make sure that when I constrain it, it constrains in the right place. So I just moved it down and I pressed OK. And you can see these two parts are just kind of floating in relation with each other. So now comes the fun part when we put all these pieces together. So over here, there's this tool called the joint tool, and it's what we use to constrain parts in relation to each other. So there's a number of options here. There's the simple joint, between two faces, and two edge intersection. What I like to do is I like to use two edge intersection for a lot of parts, because I can specify two places and then it flies into that just how I like it. I'll show you examples on where you want to use all of them in a moment, but I'm going to start with two edge intersection. So selecting that will show that I can select two edges here and two edges here, and then it'll allow me to properly constrain the part. So over here, I'm going to select an edge 1. It will gray out the grounded piece because it's not going to move anywhere. I'm pretty sure component 1 usually flies to component 2. So yeah, if that's something that's important for you to know, then now you know. So for me, I'm going to select this edge here and this edge here, right? So this face is going to intersect with this base plate on the bottom. So I'm going to select the edges that are going to be touching each other. So in this case, I'm going to select these two edges, and then it'll allow me to select 2 more edges. So in this case, the edge 1 I selected in the axle piece was this one that goes like horizontally. So I want to select the edge that corresponds with it. So in that case, it's this one. And then for this one, it's going to be here. So notice how I selected the top edges on this plate and the bottom edges on here. So if you do it right, the part just should fly into place, and it's exactly how I want it, right? It intersects, everything's nice and flush. Does that make sense? Raise your hand if you need help with this. Okay, don't worry, I'm gonna do it again. So just follow along, and I'm gonna do another part. So again, I'm gonna insert another piece. I'm going to drag it with the arrows to the general area that it's going to be. I'm going to leave a nice gap. I'm even going to move it to the side just so you can see how this works. And then I'm going to create a joint. So right here, I'm going to click on the joint tool. I think the hotkey is J if you are a hotkey enjoyer. Again, 2 edge intersection. I'm going to select the corresponding faces on this top corner. So or corresponding edges. So this edge and this edge, and then over here, I'm going to select this bottom edge here and this bottom edge here, and then it will fly into place. There's also a bunch of other options that might be useful for later. You can see the default motion type is rigid, so that means these 2 parts will be kind of fused together and they won't move in relation to each other. You can also preview what it will do. So in this case, if I preview it, you see like it kind of shakes, just to show that they're not moving in relation to each other. The other thing we're going to use today is revolve. So if you want things to spin in relation to each other, that's what revolve is good for. I mean, obviously this is not the right part to spin, so I'm going to leave it. But you can see how there's a bunch of different options for different joint types. Like if something slides, you can have it slide and all that stuff. So I like this. The next one I'm gonna do is the between 2 faces. So I'm gonna insert this 2x4 plate. And I want this plate to be exactly in the middle of these 2 pieces, right? So if we look at the Lego car, this plate spans in the middle. So I'm going to create a joint to satisfy that. So here, between 2 faces, it'll allow me to choose 2 faces for it to be in the middle of. So here, for plane 1, I'm going to select this one. For plane 2, I'm going to select this one. And then for snap, I believe you specify the center. Hello. So I selected like the middle of the top of the plate, if that makes sense. And then for component 2, I'm going to select this. And then for snap, I'm going to select the center between these. So I think if you hold down control, it will allow you to select the centers, I'm pretty sure. Whoa, it be lagging. So here I like this center, so I'm going to hold down control, and then I'm going to click on the center there. This one is like kind of the more difficult one, but it's useful for certain circumstances. Yeah, you can, but I found that when I attach it with the circles, sometimes there's a tiny gap between the two circles, so they kind of like phase through each other. It's kind of hard to see, but I found that this way makes it a little bit better. You can kind of see that like the gaps aren't exactly like aligned with each other here. So these like Lego blocks are not exactly like the same length. But yeah, again, I'm just showing you all the different like joint types just so you know. There's definitely like scenarios where you might want to choose one over the other. But the last thing that I want to show you for this is sub-assemblies. So sometimes you're going to have a part that you're going to use multiple times. So like for this car, like you're going to be using like the wheel 4 times and then the tire 4 times. And what you can do is you can create an assembly and then insert that assembly into another assembly. So it's called a sub-assembly. So what we can do is we can create a sub-assembly with the wheel and the tire, so we don't have to create that joint 4 times, if that makes sense. So I'm happy with this. I'm going to press save for now. I'm going to create a new design. I'm going to save this. I'm going to call this the wheel sub-assembly. And then I'm going to insert the tire and the wheel. So insert this. I'm going to ground it. And then I'm going to insert the tire. Now you'll see that like when it inserts it, it kind of inserts it into the right place. But we don't always want to assume that. So that's why I like to move it away from where it's actually going to be constrained, just to get a visual confirmation that when I constrain it, I constrained it where I wanted it to. So right here, I'm going to create a joint. And this time I'm going to create a simple joint because I'm going to just select an edge of the circle and then the wheel. So right here, I'm going to select this edge and I want it to be constrained to this edge here. So I'm going to double click and it should fly into place. We like that. Motion is rigid because I don't want the tire to spin inside the wheel. But that looks good. So it's usually automatic, but under the joint feature, there's the position tab and the motion tab. I'm about to do this in a second again, but the motion tab allows you to change the type of joint that you're creating. So before I insert it, I need to save it. So I'm going to save it real quick. I'm going to go back into the Lego car assembly. We have this nice frame here. What's up? You want to help him?
What?
Yeah. Okay. So we have our frame, but now we can insert our wheels. So I created two because I did this last time, but I'm just gonna do this one. Um, let's start with this corner right here. So I'm gonna move it into the general area that I want, and then I'm gonna create a joint. Now, for this one, you kind of have to be careful, and this is why um, I'm going to emphasize that you really need to be specific on where you're choosing your constraint points. So especially with this model, you can see how the center of this axle piece isn't a full circle. So sometimes you'll see that it'll select the edge of your arc instead of the actual center of the circle. So if you look at my mouse, you can kind of see this little mini origin. I don't know if you can see that, right? Does that make sense? So this little mini origin is basically where you're choosing your constraint. So you have to make sure it's in the right spot. So I recommend you zoom in a lot, just to confirm. But like what a lot of people do is they'll want to constrain to the middle, and then they'll click on this arc. And right now it's good, right? You can see the mini origin isn't on my mouse. It's actually at the center of the circle. But if I move up slightly, um, it'll choose the center of this arc, right? And then when you constrain it to the axle, your wheel is going to spin in like a non-concentric way. So to fix that, you want to make sure um, this mini origin is where you want it. So again, if I move down a little bit, it's centered. That's what you want. So I'm going to confirm by clicking it, and then I'm going to select the center of this as well. This side's a little bit easier because it's a full circle. So you can see the mini origin is like in the center of the axle. So that's what we like. I'm going to double click that. It should fly into place. And don't worry if sometimes like the part's constrained to the part that you're constraining don't fly into place. Once you like confirm the joint, it will fix all of that. So in this case, I want these wheels to spin in relation to the axle. So under motion, again, these two tabs right here, I'm going to change it from rigid to revolute. And now you can see when I change it, this axle spins nicely. So I can preview it, it spins nicely, and we're all happy. When I confirm it, you can see the tire flies into the correct place, and this spins. So I'll do it again, but then I'll show you what happens when you do it incorrectly. Yeah. So what happens, so I'm going to select the wrong arc, or I'm going to select the wrong point. So you see it's selecting this arc right here instead of the center. If I select this edge and I like try to revolve it, you can see it's like not spinning right, right? And then you're going to get really frustrated and sad, but we don't want that. So you see when I preview it, it's not really doing it right. So again, we can fix that by specifying the center. And then when we do that, it gets fixed. I believe you can actually. I've never tried it in I've never actually tried. I said capture. Let's see if it lets me. So yeah, that is a good point. You can also mirror and like circular pattern like components and stuff, which is kind of useful if you don't want to create like a million joints. So in this case, I'm going to see if I can mirror these tires. Boom. That's cool. Let me see. Oh yeah, they're just kind of like floating. So it'll like mirror the components, but it may not constrain them properly. Um, so yeah, you might have to constrain them. But yeah, that's basically this assignment. The rest of the parts are just more constraining, so I won't finish it for you. But just make sure you add appearances and make sure they're not gray, so I know that you actually changed the color. So yeah, that is fusion assembly joints. It's a little bit different if you've ever tried other CAD softwares, but it can be kind of nice. So yeah, is anyone confused on this? Okay, what are you confused about? This one? Okay, so when, oh yeah, this center one, there's a little bit of a gap on both sides, if that's what you're concerned about. This piece isn't exactly the distance between that and that wide, so that's okay. Also, when you like take a screenshot and it's like, if it's like off by like a millimeter or two, I probably won't notice, to be honest. But yeah, um, for your homework, your homework assignment is to um, create your own Lego model. So how this is going to work is you're going to be looking at different repositories online to find the bricks that you want, or you can use the bricks I've already provided for you. But I'll show you in a minute. There's a bunch of free 3D models on the internet, and it can be very useful for when you're designing something. Like basically all standard hardware has a CAD model online somewhere, and if you're looking for that, or you can be lazy and just like take it off the internet instead of like designing it, right? So like let's say you're like designing something with like a screw. You don't need to CAD the screw. You can just like find it on the internet. And that's like not a problem. People do it all the time, and it's really useful, especially for things like bearings and stuff like that. That's a really great uh, use of the internet. So in our case, we're going to be using it to find different Lego bricks, um, but you can do so much more with this. So I gave you like a couple websites that have like CAD libraries or CAD repositories. So like GrabCAD is a great one. All these like websites are really nice. Some of them ask you to create like an account, and you can use whatever email. They're usually free. Please don't pay for anything because I don't want you to have to buy anything for this course. There's like a bunch of stuff online that's free anyways. I have a link somewhere, but there's a couple of nice websites with bricks. But I'll just show you. I like using GrabCAD a lot, but okay, yeah. So if I go to a GrabCAD library, you can see how there's a bunch of models already, like that people have made public for you to use, right? If you're gonna like use it for a commercial purpose, you might want to check that. But for the most part, like these people like have these things that they've created and they put it in the public domain for you to see. So for example, we can like type in Lego brick, and you can see how a bunch of people have modeled different Lego parts. So again, GrabCAD's a great place to go. I'll post some other websites later, but knowing that these resources exist can be a really great tool when you're designing other things, right? So it's not just Lego bricks. Like let's say you're designing something again with a bearing. A 608 bearing is like a skateboard bearing. They're very common, and someone has probably CAD'd that already. So if I look up 608 bearing, you can see that like a great number of people have already modeled a bearing for me, right? So that can save me a lot of time because I really don't want to CAD bearings all day. So if I want to like find something, this is a great place to go. I know, I believe McMaster, if you know what that is, McMaster is a website where you can like buy a bunch of hardware and stuff. You can also buy stop signs. Fun fact, I thought that was kind of funny. But on McMaster, a lot of the hardware that they have is available as a 3D model. So if you buy like hardware from them, so if you buy like a certain screw, let's just find some random screw here. So there's this bolt here, right? You can see down here, there's already a spot where it allows you to access their CAD. So over here, you can like choose which file type. Usually step file is pretty good. Step is like a good universal file. I'm going to be talking about those a little bit later. But yeah, you can use this and import it into your designs, right? So let's say I really wanted this screw to be in my Lego assembly. I can download it, upload it to my Fusion drive.
Does anybody else have any questions regarding the assembly?
Oh, it's still uploading. But yeah, now you can see I have a bolt in my assembly. I mean, this is obviously not part of the assembly, but you can see how this can be really useful when you're designing other things. Does that make sense? So I really encourage you to use these repositories to find what you're looking for. And just remember whenever you're CADing after this class that these resources exist because it can save you a lot of time and it'll just generally make your life a lot easier. Yeah. Other than that, I'm just going to introduce the final project. I've talked about it a little bit so far, but it's very simple. Just it is a time where you can let your imagination go free and then you can create whatever you want. I highly encourage you to make it school appropriate because I'm going to be looking at them and I don't want to look at inappropriate things. But other than that, as long as it's not the engineering fountain or a plane or any of the other assignments we've done in class so far, it's fair game. So if you want to do like a lot of people like to model like the bell tower at Purdue, you can do that. Or you can like model something that you might want to have in your house, right? I know someone did like a toothbrush holder, and then because it's a final, I allow you guys to print them out, and I printed them like a toothbrush holder. Um, so again, your finals, the final that you make will be something that you can get printed by me. So if you want your final printed, you're going to upload your 3D file and I'll print it for you. I'm going to go in a little bit more into that next week, but like just like keep it reasonable. Don't make something like super big because there's a bunch of students that I need a print for. So Yeah. But other than that, as long as it has more than 5 design features, that's all you need. So you could do like 5 extrudes, and that technically is a final. But I really encourage you to spend a little bit more time on that to create something cool, uh, especially because that's kind of what you get out of this course, right? If you don't want to challenge yourself, you won't be challenged. But I really encourage you to see what you can do with your skills that you've learned this session. Um, but yeah, there's also an extra credit assignment if you're interested in that. It's basically creating this Amelia Earhart airplane. It's a little bit out of scope for this class because it dabbles into surface modeling, which isn't really relevant to all the other stuff that we've been working on. It's pretty cool though, so if you want to try surface modeling, you can do it. Um, Surface modeling is really good for organic shapes, so you can see how this plane is very smooth and sleek and aerodynamic. That's something that surface modeling really excels at. It'd be very difficult to model this in like one of the ways that we did in class. Like making a loft or something to create this profile would take forever. So surface modeling is really good for stuff like this. But again, it's a little bit unrelated to what we've been doing, so it is an extra credit assignment. If you want to try it, the instructions on how to do this are in the slides. Um, but yeah, other than that, that's basically all I have for you this week. Make sure you add appearances in your Lego car because I don't want to dock points. Um, but yeah, if you have any other questions, I'll stick around for a little bit.
Just to be clear, you guys do know how to apply appearances, correct?
Yeah. Okay, cool. I'll stick around for a bit, but again, I have an exam, so I kind of want to prep for it at least for 2 seconds. You sure?
Yeah.
Okay. But yeah, thank you for coming. I'll see you next week.